Well, bonjour, mateys. We are jumping into 3.5, which is about graphing linear equations in slope-intercept form. That's the y equals mx plus b. So you're going to see a lot of vocab here. Slope's one of them. Rise and run, which you use to find slope. Slope-intercept form, which I just said. That's the y equals mx plus b. Constant function. That is our y-intercept. That is our value that's all by itself. And then we have dependent variable and independent, which we've already talked about. So the independent is our x and the dependent is our y. Okay, here's a bunch of notes to take. Good luck. So, to find the slope, which is our m in our equation, or rate of change, you can find it by picking any 2 points from our line, and you find the change in y. That's called the rise. It's how much it goes up or down, divided by what's called the run, how far it goes across between two xy points. So there's a fancy formula. It's right here. All right, so I'll let you analyze this, and then we'll go through specific examples, which will hopefully make this a little more easy to understand. Okay, now that you've taken great notes, you're going to add some more to that notes. I'll put myself up here. There we go. So there's different types of slopes. You have positive slopes, which look like that. This thing, does this make it go away? Oh, it does. Look at that. So any line that goes up from left to right is a positive slope. And then a negative slope goes down from left to right, a decreasing slope. Slope of 0 is like y equals 0x plus or minus a number. It's a straight horizontal line. And then this is an undefined slope. This one, we can't have a y equals mx plus b equation for. This is just x equals something. So this is an undefined slope, and we'll see why it's undefined soon. Like, that's foreshadowing. Okay, more to add your notes. Enjoy. All right, so here we got first, to describe the slope of this line for part A here. So describe this slope for line A. Yeah, that one is a positive slope because it's going up from left to right. What about the slope for B? Yes, that one is negative because it's going down from left to right. So now let's calculate the actual slope. We'll go through A together. I won't ask you about that. So the way to calculate the slope for A is you pick any 2 points from the line. They've labeled these ones, so let's use these, shall we? And you find the rise divided by the run. So we can use the fancy formula, but I'm just going to go through how you would do it with these 2 points. So the rise, you're going up 1, 2, 3, 4 spaces. And the run is going over 1, 2, 3, 4, 5, 6 spaces. So it's going up 4 spaces from here up to here, and then over 6 spaces. So the slope is 4/6, which you can use the formula for. That would also work just fine. And 4/6 can be simplified to 2/3. Okay, now I could have picked the origin also and this point right here, and you'll see that it goes up 2 and over 3. So there's where the there we go. There's where the 2/3 comes into play. Okay, so any 2 points along this line, as long as they're easier to read, you can use to find the slope. All right, so now that we've gone over that example, try to find the slope here for line B. Okay, so hopefully you realize that it's a negative, so your answer should be a negative number, and it's going down from here to here is going down 3 and over 2. And if you use a slope formula, then these are the points you plug in. So you go -1 minus 2 is -3, and then 2 minus 0 is 2. So down 3 over 2, or -3/2, is our slope for this line right here. All right, now let's jump into how do you find slope from a table? Okay, well, tables are just points from graph anyway. So you can pick any 2 points that you want from your table and calculate the change in y, that's your rise, divided by the change in x, that's the run. So let's see which 2 points they picked for A, and we'll go through that together. So they decided, we'll just use the first 2 points on the table. So to go from 20 to 14, it went down 6. So in this case, the rise is -6. And then from 4 to 7, it's going over 3. So the run here, the change in x, is 3. And -6 divided by 3 is -2. So the slope for this first table here is -2. So you can get it from a table. You don't have to graph it and pick points off a graph. There you go. All right, so try to do B. I'll leave this up if you want to pause and take notes. Okay, and now let's try to do B. Oh, look at all these extra things they're throwing in here. Oh yeah, and you can also plot these points on a graph to make sure that the slope is indeed -2. All right, so take a look at B. See if you can calculate the slope for B. All right, so this one, a little tricky because there is no rise at all. If you pick any 2 points here, the y value stays the same. This is a horizontal line, which means the rise is 0 for any run that you have. So it's a slope of 0. So this would be a horizontal line, which you could graph and see that for every point, the y value stays at 2. So slope is 0. There we go. All right. Try this one right here. What do you think for the slope on C? Okay, this is where the undefined part comes in. So you can pick any 2 values for y and find a difference, but when you pick the values for x and subtract, you'll get 0. This cannot happen. The universe explodes if you have 0 on the bottom of a fraction or try to divide by 0. Can't be done. That's why this is called undefined. So this is a straight vertical line. So that slope is undefined. There is no slope calculable if it's a vertical line. Okay, let's see what we got here. Oh yeah, now we're going to tie back in the slope-intercept form. We've gone over slope quite a bit. Now, that's our m in the y equals mx plus b. That's our rate of change. The y-intercept is just where it hits the y-axis. It's what the y value is when x is 0. So this is another great little page to take some notes on. Enjoy. And now let's jump into some examples. So for this first equation right here, you might want to check back your notes. What is the slope and what is the y-intercept for this equation, for equation A? Okay, the slope is a number next to the x, and the slope here is 3. The y-intercept is -4 because it is a -4. What that means is if you were to graph it, you would have the line cross at -4 on the y-axis, and then it's going to go up 3 over 1, up 3 over 1, up 3 over 1 every time. That's how it works. I don't think we have a graph for that. All right, so now for B, if you just have y equals a constant, you can rewrite that as y equals 0x plus that constant. So 0x plus 6.5 is the same as y equals just 6.5. So for B, what is the slope and what is the y-intercept? Yeah, the slope is 0 because it has no slope. Y is 6.5 is a straight horizontal line through 6.5, which ends up also being the y-intercept. Okay, C, I think we get a whole new slide. Well, let's see what this says. Constant function, every input has the same output. Yeah, so that's why it's a horizontal line, because every input gives you 6.5 straight line across. So C gets its own slide. There it is. Okay, this one you might want to do on paper because you're going to have to rearrange a little bit. So rearrange that puppy into slope-intercept form and then tell me what is the slope and what is the y-intercept. Okay, once you rewrite it and get y by itself, which I believe they go through the steps, here are the steps, you'll end up with y equals -5x plus 2. So the slope is -5 and the y-intercept is 2. So this leads to how do you put this on a graph? I think that's the next thing we're doing. Y it is. So we have to graph this puppy right here, 2x plus y equals 2. This is in standard form. One thing, and then also identify the x-intercept where it hits the x-axis. So one thing you want to do is rewrite this equation into slope-intercept form. So what do you get when you rewrite 2x plus y equals 2 into slope-intercept form? All right, you get -2x plus 2. So you subtract 2x on each side, and there you go. So the slope for this one is -2, and the y-intercept is 2. What that means is you're going to put 0, 2, that's our y-intercept, on the graph first because that's where it has to cross the y-axis. So when you have slope-intercept form, take the y-intercept value, boom, stick it on the y-axis. And then our slope of -2 means it goes down 2 every time it goes over 1. Rise over run is -2 over 1. So from this point, you can go down 2 and over 1. I think they go over 1 and down 2. It makes no difference. As long as you go on a negative slope. So it needs to go that way when you're done. So down 2 over 1 puts a point right there. And that is also our x-intercept, which is 1, 0. And there's our line. You just make a straight line right through it. Boom, there's our equation, graphed. Nicely done. Okay, so again, the x-intercept is 1 or 1, 0. And I believe we have a real life equation. Go ahead and take notes on that if you'd like. Okay, so here's our real life equation. So, wait, oops, you weren't supposed to see that. Pretend that you didn't see that. Okay, let me refresh this part. Woo, okay. So we have a submersible that is exploring the ocean floor, and it begins to ascend to the surface. So would that be a positive or negative slope? Yeah, it's going to be a positive slope because it's going up. It's ascending. And the equation is h of t equals 650t minus 13,000. So first, I want you to just analyze that equation and tell me how deep is this ocean floor that it's at. Yeah, it's 13,000 feet below surface level because that's what this negative 13,000 is. That's our y-intercept. So it's important to understand this problem. And then how much is this submersible increasing every time t goes up by 1 minute? So every time t increases a minute, how does the submersible increase? It goes up 650 feet every minute. So if we were to graph it, we only need quadrant 4 because it's starting at a negative below sea level value, and it's going to get up to surface level, which is at 0. So it never actually attains a positive height because we don't want our submarines flying through the air. No bueno. So it's going to start at negative 13,000. So that's where you would plot the first point because that's our y-intercept. And then it's going to go up 650 every time. So every time you go over 1 minute, you go up 650 feet. And you'll eventually end up, boom, right here, if you make a nice, lovely graph. And you'll find out that at 20 minutes, that is where this thing ends up hitting the surface of the water. So this one will have a domain that goes between 0 and 20 because we don't have negative minutes. And once it hits 20 minutes, it is surfaced, and we don't have to go any further. The submarine's not going to fly away. We don't want that. And again, that's our what x can be. In this case, t is our x variable. And then the range is from negative 13,000 up to 0 because it goes from the ocean floor up to the surface, which is 0. Okay, and again, they're using t and h instead of x and y because those are the variables that we're using for our domain and range. Okay, so that's a lot. Hopefully, we're able to take some notes on slope and how to calculate it with rise and run. And how to graph those using the y-intercept and the slope. And that's what we'll be working on in class. So make sure to ask us questions if you have them, and we'll see you in class.